Hi friends, welcome to this class. So we were discussing stereochemistry other than carbon, right? So here I have taken few examples, including all the like sulfur, arsenic, phosphor, everything, right? So let us see these things, right? So in exams, what they will do, they will give a compound like this, right? So which I have written it here. So this is my first compound, which I am showing it with red color, right? So they will give compound. So they will tell whether it is optically active or not, right? If you see, I have explained in arsenic stereochemistry of arsenic there. If arsenic is attached to different like A, B, C, and D, different atoms, so it will get positive charge if it forms 4 bond. If it forms 3 bond, no positive charge because there will be lone pair, right? So anion will be there. Then in such compound, this will be optically active. Just you have to write optical active, right? But if they ask to do R and S nomenclature for this compound, so no need to do, no need to worry. Just what you have to do is see, if you have compound this, if you see the priority, first priority, this will be 1, right? Second priority, this for this it will be 2. The third priority is for ethyl and fourth priority is for methyl, right? So this is the priority order. So just what you will do, 1, 2, 3, it is anti-clockwise, right? So this is like this, anti-clockwise. If it is anti-clockwise, just you write it as yes, simply if you do, right, like that. So don't say above, below, those things, right? So if they never ask you R and S for these compounds, just they will tell you whether to tell R and S optical active or not. Just you have to tell it is optically active. If they asked, you simply do this thing, right? So this is the second compound. Coming to the second compound, if you see, about this also I have explained in nitrogen. So here it is like C double bond C double bond C, right? So it is like this. So here I have H, here I have COH, and here I have H, here I have COH, right? So this is nothing but allene kind of molecule. I call this C triple bond double bond, right? These are called allenes. So here also this is kind of allene only, because I told one double bond is equivalent to one ring. It can be 6-membered ring or 5-membered ring. So if you see, we always tell that here one of the hydrogen, here this hydrogen can be below and this COH can be above, right? Whereas these two will be in plane. This will be in plane and these two will be out of plane. If you see the stereochemistry of allene, if you have studied, there you will get that it will be out of plane and it will be in plane. So what happens, there is no symmetry elements like plane of symmetry, center of symmetry, axis of symmetry, mirror plane symmetry. All the symmetry elements will be absent, because of which it will show optical activity. So if they ask you, so you have to write it is optically active, right? So this is the thing, right? So if they asked you for R and S nomenclature, so no need to worry. Just assume that this is, sorry, yeah, this is in plane, right? So if you see this hydrogen and COH is more bulky, so one priority to this, second priority to this hydrogen, right? And coming to here, third priority to this COH and fourth priority to this H, right? And if you see the arrow, it should be like 1 2 3, right? So it is like 1 2 and 3 here. So it is like 1 2 3, right? Because 1 is here, 2 is here, and 3 is here, right? 1 2 3. So it is moving like anti-clockwise, right? So anti-clockwise means it should be yes, right? Since here hydrogen is also below the plane, so yes remains yes. So it is yes only, right? So if hydrogen was above, then it would be a different thing. For example, if I take it here, you will get to know, right? Here if I take allene like this, C double bond C double bond C, here I have COH, here I have H, let us assume, and here I have H above the plane, and here I have COH below the plane. So if you do R and S nomenclature, so first here 1 2, here this this COH3 and this hydrogen 4. So it will be like 1 2 3, right? So it is clockwise direction. You assume that it should be R, but the thing is this hydrogen is there, right? The fourth hydrogen, it is above the plane. So when it is above the plane, fourth priority, the R becomes yes. So if you do nomenclature, it will be yes. Right. So always while doing number 1 2 3 4, you should see that the atoms which are in the plane should be given 1 and 2, right? And the atoms which are above the plane, below the plane, at the third carbon here, this carbon is different, here I have one more carbon, right? There you will give the priority again 3 and 4 based on atomic mass, right? Then you will do, if it is clockwise, then it is R. If it is anti-clockwise, then it is S. If fourth priority is above the plane, fourth is above, then R becomes S. Here also, if fourth priority is above the plane, S becomes R. That is how you should remember these rules, right? These all things you have studied, so I didn't tell it in this stereochemistry other than carbon, because you have studied in all those basic stereochemistry, and also in stereochemistry of allenes, so many compounds, helical compounds, there you have studied, right? So this is the thing. So about this thing also I have explained it arsenic, in arsenic, stereochemistry of arsenic. There if you see it, it looks like in plane only, but the thing is this arsenic is there, right? So one of the ring will be above the plane like this, and one of the ring will be below the plane like this, because of which what happens, there will not be any symmetry elements. So here it will be like this, right? One is above, see as it is, one is above here, this two, and one is below the plane. So here no symmetry elements like plane of symmetry, center of symmetry, axis of symmetry, mirror plane symmetry. So these symmetry elements will be absent, because of which these compounds will be optically active. These compounds will be optically active, right? About this also I have told while explaining the inversion, pyramidal inversion, right? Nitrogen inversion there, pyramidal inversion, pyramidal barrier I have explained, right? Oscillation frequency, so many things I have explained. So here if you see, the substitution at this nitrogen is different, this one is different. Here this CH2 is there, here it is C attached to CH3. So all are different. Here it is A, here it is B, here it is C, and nitrogen will be having lone pair, that is D. Since all substitutions are different, and also this nitrogen is restricted. Restricted means no pyramidal inversion. Why here no pyramidal inversion? Everything I have explained it, right? So such compounds will be optically active. So if they asked you in exam, you should tell whether it is optically active or not. Here no pyramidal inversion, so it is optically active. If they give you compound like this, see, right? Here also no pyramidal inversion, no pyramidal inversion. Whether it is optically active or not, it is optically inactive. Here, if pyramidal inversion is happening, then no doubt it will be optically inactive. But here no pyramidal inversion, because it is restricted molecule. But then also it is optically inactive. The reason is it has got plane of symmetry. Right. So this chlorine, nitrogen, and like this it will be plane passes. And here if you see the adjacent term, this chlorine is A, here it is B, this is also B. So the substitutions are not different, four substitutions present on nitrogen, right? So because of which it will be having some symmetry element, here it is plane of symmetry, so such compounds will be optically inactive, right? So here if they give you like this, see, here methyl is there A, this is atom different, here I have this compound which is B, and here I have C, and on nitrogen lone pair will be there, that is D. So all different substitution, so this nitrogen will be like asymmetric, so molecule itself is asymmetric, so no plane of symmetry, no center of symmetry, no axis of symmetry, no mirror plane of symmetry, all symmetry elements are absent, so the molecule is optically active. All right. So coming to this, I have told butterfly configuration it will be having. That I have told you while talking about arsenic, right? Here at this axis, there will be folding. So like it will go below, this is also go below. And here no symmetry elements, all these symmetry elements. Symmetry elements means only these things only. Plane of symmetry, center of symmetry, axis of symmetry, mirror plane symmetry. This is mirror plane symmetry. This is axis of symmetry. This is plane symmetry, and this one is center of symmetry, right? All the symmetry elements will be absent. So whenever the symmetry elements are absent, such compounds will be optically active, right? And also I have told so many things of geometrical isomerism, right? Whenever we have sp2 hybridized, they will show geometrical isomerism, not the optical isomerism. Those things I have explained it, right? Coming to this compound, if you see that here also one of the bonds will be above like this and other bonds will be below like this, because of which they won't have any these symmetry elements. All the above symmetry elements will be absent, so these compounds will be optically active, right? Optically active, right? And these reactions, in case of sulfur, stereochemistry of sulfur I have discussed this reaction. Stereochemistry of phosphor I have discussed this reaction. So in exams they will give only this much. They will ask you to tell the stereochemistry other things, right? You have to write about them, which I have explained it. You can watch those videos, right? And also you can see this reaction, I have explained about it, right? Just it will like SN2 reaction, but the stereochemistry of the product also remains the same. So retention of configuration, plus remains plus, so it is a retention. Whenever plus becomes minus, we call it as inversion of configuration. Whenever plus remains plus or minus remains minus, then we call it as a retention of configuration. Everything we have discussed in the reactions, right? So sometimes they will ask you identify optical activity and geometrical isomerism in such compounds. So these are the two compounds they have given, and they have asked the question is comment on the optical activity and geometrical isomerism. They will ask like that. So the thing is, see, taking this compound, so this is sulfur attached to double bond O. Here I have para position methyl C6H4 CH2, here propyl. So all the substitutions are different here. So this one is A, this is B, this is C, and nitrogen is, that is sulfur will be having lone pair because valence is 6, right? So that will be D. Since all substitutions are different, so it will show optical activity. Why it will show optical activity? Since all substitutions are different, so no symmetry elements. So symmetry elements are absent. Plane of symmetry, mirror plane symmetry, axis of symmetry, center of symmetry, all these elements are absent. Sorry, all these are absent. So this will show optical activity. Coming to this, about this also I have talked. So what it is, just I will write it here, just to check it. So it is like yes, sorry. So the structure is like this, right? 6-member ring, double bond O, double bond O. I told it can exist like this, right? Yes. So it is like 6-member ring, double bond O can be like this, or it can exist like yes, double bond O here and double bond O here, like this, right? So cis trans geometrical isomerism they will exhibit, I told, because they will be having some plane of symmetry. If I take a plane, that plane will cut this oxygen sulfur like this into equal half, and this CH2 will be mirror image of this CH2, and this CH2 will be mirror image of CH2. So it will be having plane of symmetry. So plane of symmetry means it will be optically inactive. So such compounds will show geometrical isomerism. Geometrical isomerism, that is cis or trans, it will show like above. I have told these things I have discussed in sulfur compound thoroughly, so I am not going to tell the answer here, right? And also they will tell you, they will give these compounds as I have written here, phosphor. They will give these three compounds and they will ask you to tell the stereochemistry of such compounds, right? So these things also I have explained it, right? Since substitutions are different, it is also optically active, so it will show either plus or minus, right? So optically active, here also it will show optical active. It is called phosphonium salts as it is forming plus and minus, so it is called phosphonium salts. About these things also, and this is nothing but phosphonium oxide. So here also all four substitutions are different, so this is also optically active. This is also optically active, right? All these are optical active, right? Because substitutions are different. Just I have discussed about phosphonium, phosphonium salt, phosphonium oxide, everything. These things I have discussed thoroughly in the class, right? So I hope all the things I have made you clear. So if you like these videos, share with all your friends. And if you are not the member of my channel, please do subscribe it. Give me a like button, right? So thank you for watching. Thank you.